All right, students. So today what we will do is discuss this question. You can read it. So you can see in this question you have the uh, a body which is moving in a circle, and this body which is moving in the circle is also having a point outside it, which you can see as the point P. The question is, what is the situation of angular momentum, right? So you can see the multiple choices which are given where we need to articulate what is the angular momentum of this body with respect to this point, right? So generally what happens is, if you have this circle, right, and you have the body having some linear momentum, for example here, right? So this is your mv, right? So if I have to calculate the angular momentum of this body with respect to this point, this is what I do, right? I stretch the direction of linear momentum like this, and I drop a perpendicular here, right? I drop a perpendicular. So if I know this distance x, my angular momentum with respect to P is going to be mvx, right? So this is the situation of angular momentum of a point mass about an axis which we have chosen, right? So depending on the axis, the angular momentum will keep on varying. Assume a situation, the body is here, right? So the body is here. This is mv, and the distance now from the point P, okay, is this. So now this distance becomes x, right? And we extend this. So now the angular momentum is mv x dash, right? So angular momentum of a point mass is completely dependent on the chosen point, and therefore the distance keeps on varying. Because it's a circular motion, uniform circular motion, the velocity is not changing, but the distance of the body from the perpendicular distance of the direction of momentum is continuously changing. So if you notice, this is the direction of momentum and this is the distance. These things are changing, and therefore that is causing the change in momentum at different points on the circle. Assume this point, right? So you have this point where your linear momentum is in this direction, right? So if your linear momentum is in this direction, the perpendicular distance, so extend the linear momentum direction and now drop a perpendicular line like this, right? So you have, this is your new x, the distance, the perpendicular distance from the direction of your mv. So your new angular momentum is mvx, right? So right now I'm just focused on the scalar part, which is the magnitude of the angular momentum. We're not really worried about the direction of the angular momentum. But if you want to understand how to calculate the angular momentum direction, very important topic, please go to my playlist of rotational motion, and you will see numerous conceptual questions which will help you understand the angular momentum of a single body around a point where the axis is residing. Now, the question says, the question is talking about specific scenarios. So it says angular momentum will be always zero with respect to P. I don't think so, because the angular momentum is, I calculated it here, I have calculated at this position, and then I've calculated at this position. It does not come out to be zero, right? That is outrightly wrong. Now let's do more discovery and find out what exactly is happening, right? So if I have to find the points at which the angular momentum actually is zero, I will use the basic definition of angular momentum, which is m, right, and v and r, right? So the real value is mvr sine theta, because the angle between the distance from the axis of mv is very, very important, right? So all the positions I took had 90 degree, right? So this was 90 degree, this was 90 degree, and so was this, right? So this is actually MVR sine 90, right? So this is MVR sine 90 and this is 1. Okay? But the journal formula is MVR sine theta. So if I am able to find the values where MV, the momentum, and R are in the same direction, right, the theta will become 0 or 180. If I draw a tangent from here, right, if I draw a tangent from here like this, right, so assume this is a tangent, this is my R and my velocity is also a tangent, right? So assume that my momentum at this point is in this direction and this is my R. So you can see the R, okay, the R and the linear momentum, right? They are in the same direction, right? Similarly, if the body is moving in this direction, so let me draw a tangent to the circle here, right? So if the body is coming like this, and for example, it is located here, your MV is along the tangent, right? But your R, which is this distance, right, is in this direction. So here the angle between MV and R becomes 180 degrees, right? So this is 180 degree. So therefore, if I calculate the angular momentum here, it is MVR sine 0. If I calculate it here, it is MVR sine 180 degree, right? So this is equal to 0. This is equal to 0. That is the way we need to look at this question. The angle between the R and V is 0 or 180 degree, right? If we know that, so we could decipher that we have two positions where the angular momentum comes out to be 0 in this case. So the correct answer, you can see the correct answer is two positions the angular momentum is 0. So the story of the question is, or the, so to say, the lesson learned is, whenever you're attempting the angular momentum problems with a point mass, right, and you're supposed to calculate a scenario, what is happening to the angular momentum, always concentrate on the directions, which is the direction of the linear momentum and the vector, you know, which is drawn from the P perpendicular to MV, right? So this was MV and this was a perpendicular to the direction of MV. That is the way you need to look at the problem. Do not ignore the angle between these two whenever you're, the linear momentum and the vector which is drawn from the point about which the axis is taken, the perpendicular to the linear momentum direction. So I hope you like this video. Please don't forget to subscribe to this channel. We are the only channel which is giving good explanation of the concepts of physics. All the concepts which you can think of are available. This channel will help you prepare for the exam. Numerous conceptual problems for understanding and practicing for NEET examination, JEE Mains, IB Board, AP Physics, State Board, Dexel, Cambridge, so on and so forth. So this is a channel which is giving excellent explanation. That's a key differentiator. This is the way we look at ourselves, and therefore spread this channel, help your fellow students and the fraternity. Please also don't forget to join my community. I keep on putting some interesting questions on physics which you can attempt with explanations also available. So it will help you give a lot of practice on physics. Thank you very much and wait for my next video.